Hello and welcome to Easy Maths. This is the second lesson, in which case we're going to tackle the solution of linear inequalities. And this is in a series of lessons on linear programming topic. And let's go straight to the part of today's lesson. So before us is a question where we're told that someone wants to pay workers wages and the current needs 5 shilling and 10 shilling coins besides currency notes, and he needs at least 40 5 shilling pieces. The number of 10 shilling coins must at least be double the number of 5 shilling coins. The sum of money must not exceed 1500 shillings. So we thought find all possible combinations of 5 and 10 shilling coins their current needs. Let's say that let x be the number of 5 shilling coins and y be the number of 10 shilling coins, and therefore with that information we can say the number of 5 shilling coins, there's an inequality about that, which is implied this way. We're told he needs at least 40 5 shilling pieces. That means the x, that's the number of 5 shilling coins, should be more than 40. That implies an equation x is equals to 40, and it's a vertical line at x is equals to 0. Again, the number of 10 shilling coins, we've been told again that the number of 10 shilling coins must at least be double the number of 5 shilling coins, and therefore y is greater than or equal to 2x, and therefore we have an equation like this. And if you set x to be 0, y will be 0, and if you set x to be 10, y will be 20. The number of 5 shilling and 10 shilling coins, therefore here we have been told that the sum of money must not exceed 1500. Now if we have x times 5 and added to y times 10, should not be more than, so should be less than or equal to 1500. This means that x times 5 is total money that is in 5 shilling coins. Y times 10 is the total amount of money that is in 10 shilling coins. And the sum of those two should not be more than the amount, 1500. So we have the inequality 5x plus 10y is less than or equal to 1500, which simplifies to x plus 2y is less than or equal to 300, implying the equation x plus 2y is equal to 300. If you set x to be 0, y will be 150. If you set x to be 300, y will be 0. Now before us is the Cartesian plane, the drawing of the 3 lines, and they're labeled x is equals to 40, y is equals to 2x, x plus 2y is equals to 300. Remember, in this case I don't have y is greater than 0 or x is greater than 0 because those ones are kind of overshadowed by the kind of operation we're going to be doing here. Now we're going to progress to shade the unwanted regions so that we get the possible combinations of x and y. So as we go ahead, I'm going to say that for the inequality x is greater than 40, we're going to test which side we shade by using the point. We're just going to shade because we know that x should be a number 40 or bigger than 40. Say 40, 41, 42, 50, 60, or any number bigger than that. And therefore we don't want the smaller numbers that are smaller than 40, and so we just shade that particular way. We don't want numbers that are less than 40. We want the numbers that are bigger than 40 that particular way. For y is greater than or equal to 2x, we're going to test that using the point P 100, which is that point there. I picked a point other than the origin because for this inequality, this line passes through the origin, and therefore I don't want to use the origin. I want to use a point that is not the origin. Now we can see which side this point is as far as y is equal to x line is concerned. Now if we put x to be 100 and y to be 0 in this inequality, we're going to get this sort of inequality, which is 0 is greater than or equal to 200, and this is mathematically not sensible. That means that point P 100 is in the unwanted region, simply because this inequality we got here is not mathematically sensible, and so we write it that way. Point P 100 is in the unwanted region, and so we shade the point P side that way. Similarly, we move on to x plus 2y is less than or equal to 300. We test again using the point P 100, putting x and y to be 100 and 0 respectively. On that particular inequality, we get this kind of a thing, and so we have 100 is less than or equal to 300. This is mathematically sensible, And that means that point P 100 0 is in the wanted region. Okay, so we don't want the other side, and we shade it away that way. We want the wanted region, which is the side where P is, and therefore the combination of 5 and 10 shilling coins falls within this small triangle. Well, I should say that in this particular drawing we have before us, it looks rather small, but it's a very big one if you look at the scale. This is 50 and this is 100. That means we have 50 values between there, and also this is 100 and 150, so we have 50 values in there, and therefore that tells us that this is a very big region. And so I move on to explain this by first of all extracting the region R. Now the solution therefore will be, if you look at this way, I've expanded the thing here. All points within the blue, the green, and the red lines satisfy the number of x and y, the number of x and y that are possible combinations of the 5 and 10 shilling coins. I've just picked all these points that I've marked with I've marked on the screen there, like the point 4288 or 4492 or 4696, 42102. All of these points, so long as they are within this region here, and because our lines were continuous, even the points on the line are satisfactory. So let me say the set of points are, I've just listed these ones, but there are so many of them, I could not write all of them. The 6120 is this point, the 4130 is this point here, and the point 4080 is this point. So all points within the 6120, 4130, and 4080 satisfy along the line and within the region, and that becomes our answer for that. I cannot list all of them, I just listed some of them, but you can go ahead and fit as many as you want. However, I should say that these questions normally don't come this particular way. The way we normally finish it is tackled in the next subtopic in optimization, so check out for that. At this point, I'm going to say please like, subscribe, and share, and I'll appreciate your comments also. Thank you.